Hi, I'm Syed.
Hi, I'm Austin Balo.
And I'm Scott.
And I'm Carly.
And this is our physics project.
What are we doing?
For our physics experiment, we're testing the myth of whether or not a duck's quack will echo. And in this experiment, we will be analyzing the echo delay and intensity versus time of duck and various animal sounds to determine whether or not a duck's quack echoes and how it compares to other animals.
Well, quack.
Nice. All right, so next I'm going to talk to you guys about how an echo works. So if you've never heard an echo, I'm sorry, but basically what it means is that sound comes from a source. And what it does is it travels in like a wave-like pattern until it hits another object. So in this case, we're going to say a wall. What this then does is that the sound bounces back off the wall and travels back towards the source, and that's how you hear an echo.
Before we conduct our experiment, what do you think we should take into consideration?
Well, we should definitely pay attention to the type of material that the sound is bouncing off of, because if it's too bumpy, then it's going to absorb all the sound, nothing's going to reflect back, and we're not going to get an echo. So do you guys know any locations where we could produce really good echoes?
I think a good spot to conduct our experiment would be the racquetball courts at IM West. They're made of laminated particle board, and the floors are wood, and they're pretty hard surfaces that we should get good echoes off of.
Sounds good. So, guys, I just realized an issue we might have with the racquetball courts. Even though it's a great place for echoes, when we're picking up data with the IO lab, we're not just going to get like one direct source of an echo, because sound is bouncing all over the room. So what instead we'll get is one continuous echo, and then on the IO lab, when we look at a graph, we're just going to see the constant peak. We're not going to be able to tell what the real echo is. So what do you guys think about that?
I think we could actually fix that problem if we created a box around the IO lab where if we had the microphone in front, and then around the sides of the box we had sound absorptive materials. When the sound came in from those other directions, it would be absorbed by the sides and wouldn't be picked up by the IO lab, giving us more accurate information on the echo and the intensity.
Could you draw it out for me real quick, or what you're trying to show?
So here's a racquetball court, and we're collecting our data from right here. Normally, when sound goes in, it can go and come back, but if the sound comes out this way, it can be reflected all around and end up back at the IO lab, giving us a mixture of different echoes. But if we have a box around it with absorptive materials on the sides, then most of the sound coming from odd directions will be eliminated, giving us a more accurate depiction of the time it takes and intensity for an echo to come back to the IO lab.
Cool. I think we can do that, right?
Sounds good.
Starting.
Oh. Okay, we're at IM West, and we seem to have run into a technical difficulty.
That's right.
Right.
Explain. All right, after going to IM West, they're doing work on all the racquetball courts, and they're all closed, and we don't know where to go.
We need a plan B. Plan B, we're going to go to IM Circle and see if we can find a good acoustic.
Here is our apparatus.
Oh, that's a beautiful apparatus.
It is so beautiful. The foam cancels out noise, and we're going to place the speaker in here with the IO lab.
Yeah, I
Therefore,
see
the sound comes out, in, and out from this direction, so we only get one echo.
that. Awesome.
Yes.
Let's do this.
Alright, after striking out with the racquetball course, we decided to go to IM West, and we are in this hallway outside the pool. And if you look at the materials and all this, it's a very good place that we can produce an echo. And Carly can explain more about that.
So we wanted to test to make sure that we are producing an echo in this hallway. So we can do that by holding up the IO lab while we make a really loud and direct noise, and we can watch for the wave frequency.
Cool.
When we analyze our actual data, it should look something similar to the test data we just took. There should be these large spikes which represent the initial sound produced, and then the small bars afterwards represent the echo from it. And we'll be analyzing that to see whether or not a duck's quack truly echoes.
This is our test run. I'm about to make some noises, and you'll see them reflected on the graph below.
Now that we've finished the test runs, we're gonna actually try it out with a duck call.
To the sharp clicking noise and the long quack sound, we're going to have a third noise that's not sharp nor long. So we're going to do a whistle.
So sad. Why did we not end up using our box again?
Oh, it was because the peaks weren't differentiating enough when we actually used the styrofoam and the box compared to when we didn't, so we just cut it out.
Okay, so it was about the graphs of the intensity of the
Yeah.
sound. Okay. Interesting.
Hi there. So to conclude whether or not a duck's quack truly echoes, we have to look back at our data. And I've put two of our graphs side by side here, and they're both comparing the intensity versus time of different sounds. The bottom graph represents the click noise we made, and the top graph are the duck calls. And on the bottom graph here, you can see the initial click is a very sharp noise, and if you look at the second graph here, these following spikes of intensity represent the echo that is heard afterwards. And if you look at the top graph over here, you see that those are much more mixed. And Austin can explain why a duck's quack sounds like it doesn't echo.
Pencil. So the reason for this is that with the sharp noise, you have the initial sound and then the echo is what you have left. With a quack, it's a little more drawn out. So you have the echo right here mixing in with like the fall off of the quack itself. Because the delay between the echo and initial noise is very, very short. Therefore, you have the intensity of the echo mixing in with the back half of the noise itself.
So what can we conclude, Carly?
I think based on this myth, I think we can conclude that a duck's quack does echo. Their echo gets mixed in with the initial quack. Does that make sense?
I concur.
Yeah. I think the graphs represent that very well.
Mm-hmm.
So here we have a VPython simulation of a duck sitting at the end of a hallway. It's going to let out a large quack, and we're going to see the sound wave pass through the hallway and reflect off the back wall and come back towards the IO lab, which is right underneath the duck. So let's see what that looks like. Let's go. So let's move this to the side. Quack. And it's reached the IO lab. Okay, so we've got this large initial peak here, right here. This is the initial sound that the duck releases. This is the echo sound as it bounces back from the back wall and comes back to the IO lab.